Welcome, this is Conics 3, the third class in a set of classes about conics. And today we're going to cover the hyperbola. So, as you all know, if you were here yesterday or watched the videos, the previous topic was ellipses, and we needed 5 things in order to describe the ellipse. We needed to know the center, we needed to know the vertices, we needed to know the co-vertices, we needed to know the foci, and we needed to know the eccentricity. Thankfully today, with the hyperbola, we also need to know 5 things. We need to know the center, we need to know the vertices, we need to know the co-vertices, we need to know the foci, and we just need one little difference, which is the eccentricity is gone, and we now have asymptotes. But asymptotes are just as easy, really. Maybe a tiny bit harder, but not difficult. Look of the ellipse is totally different from the hyperbola, but the process by which we find the important pieces is basically the same. So let me just show you a picture before we do anything else. This is our trusty circle. You can see that if I stretch it out a bit, then it's no longer a circle. Of course, it's now an ellipse. We covered that yesterday. The connection between a hyperbola and an ellipse is actually the eccentricity. If we have a number less than 1 for eccentricity, it actually is an ellipse. If we have a number greater than 1 for eccentricity, it kind of flips inside out and becomes a hyperbola. Just look at this, okay? That might not look like they're connected right now, but let me just turn a few things more on. See how when we change the ellipse, it's actually changing these crazy curves too? Instead of being a circle or an ellipse, it kind of like turns inside out and then does this crazy parabola looking thing. It's not a parabola, but it's similar to one. And we'll see today that they're directly connected. That's why there's so many similarities. And we can do what's called, well, one version of calling it is the box method for figuring out how to draw it. We kind of deal with A and B again, where we have a distance from the center and a distance from the center in the other direction, the vertices and the co-vertices. You'll see here that these are still our vertices for this case. These are still our co-vertices. And what we'll end up doing is we draw a box that connects those. Go straight up and down and straight over. And then what we're going to do later is we're going to draw a line through this, and we'll see that those hyperbolas actually follow the lines that we drew, called asymptotes, lines that the curves never touch. So that's the basic idea. Again, most of what we're doing today is following from what we did yesterday. So if you understood yesterday, paid attention, you shouldn't have much trouble. And just for fun, I'm going to turn on all the pictures here. So look at this. Open everything up. Okay, this is our full picture. Our ellipse, our hyperbola, all on one big graph. We've got the box, we've got the asymptotes, we've got everything. Woo! It's not that crazy. Let's reset it. Now it's just a circle again. Let's get started on. So the hyperbola is a set of coplanar points such that the difference of the distance of the 2 fixed points is constant. Okay, you don't really need to memorize that. What it means will become clear as we go through. So the transverse axis is something we never had before. What we had before was the major axis, yeah? So the major axis was always the one that was related to A. That's no longer the case. The transverse axis in this case is still related to A, but it's the one, let me go to the formula. The transverse axis will be whatever is related to the first term in our equations. What I mean by that is if it's like x squared minus y squared, the x squared piece has the A, and that's our transverse axis. It goes in the x direction. If the y squared comes first, that's our transverse axis, and it's going to be related to the y direction instead of the x direction. Okay, that's the big difference. In fact, that's the biggest difference between ellipses and hyperbolas. With ellipses, we have the major axis, the longest axis. Hyperbolas don't have that. So it's actually, in a way, it's easier, and in a way, it's more difficult. It depends on how you look at it. The conjugate axis is always the one that comes second, or the negative term. So if the x comes first, then the y piece is the conjugate axis. And if the y comes first, then the x piece is the conjugate axis. And I'll explain what all this means very soon. And you should see we still have this C coming up. We have distance from center to focus. A is still the distance from the center to the vertex, and we'll see that B is still the distance from the center to the co-vertex. All of that stuff has been carried over from the ellipse. So we don't really need to go back through it. Notice that C here has a different formula. Now it does match the Pythagorean theorem. Just as a side note here, before for the ellipse, we had a squared minus b squared for the ellipse. Now for this case, we have a plus. Small but important difference. So I'm not going to over talk on this. I want to go through the problems. You'll see that these are very similar to the ellipse, as I keep saying. So if you're okay more or less with the ellipse, you'll be okay with the hyperbola as well. Notice here, the x squared piece came first. The first piece always has the a. It's not necessarily the longest axis. But what is important, and this is kind of like your cheat for how this goes, if the x comes first, or I should say, if the x squared comes first, the way I remember it, there's two ways to remember it. The first way is that the graph will go through at some x value. That's one way to think of it. One way that I like to think of it, because I think more visually and more generally, is it looks like an x. What I mean by that is the curve will look like this. And our focal points, our foci, like that, okay? Notice the x term came first, and I'm talking about it like this. It came first, the curve will look like an x. We can know that ahead of time. If the y comes first, it doesn't quite look like a y, but it sort of does. If you drew a y, but only went halfway, I don't know, it's harder to make the connection there. But the x squared comes first, it looks like an x. If it doesn't come first, it doesn't look like an x. It looks the other way. Okay, let's get started. I'm assuming there's no questions yet. Are there any questions yet? There's kind of not much to ask yet. It's just a whole bunch of information I'm throwing at you. Maybe I'll ask if there's a question once. So let's get started. Oh, the asymptotes. There's kind of a cheat for this as well. I'll get to this very quickly, but everything about the asymptotes, basically, this is just your formulas. Use them as a reference. This is how you get the lines that go in that direction, like those dotted lines I showed you on the diagram. But the important thing is this. What changes for the asymptotes, everything is always the same. You'll notice y minus k, you steal it from the original equation. X minus h, you steal it from the original equation. But sometimes it's b on top, sometimes it's bottom. I'll write a note here that you can look at later. The plus or minus b over a, or the plus or minus a over b, really what it means is that you have your term, your a or b, whichever one's related to the y value first, divided by whichever one's related to the x value. And I'll come back to that, okay? Just trust me that we're going to steal it from y and steal it from x when it comes up. I don't want to overtalk it, it's not going to help. And finally, this is an asymptote. How is it an asymptote? It's because if we rearrange it, divide both sides by x, for example, we can get x is some constant over, sorry, y is some constant over x, or x is some constant over y. So sometimes we see things like that, 1 over x, and it looks like that. But I'm not gonna, let's not worry about that too much for now. It might come up later. But the point of today is hyperbolas. Tom did these. So let's start with practice 1. Let's get into the meat of it, okay? I'll start you with a nice example that has every piece that we're gonna need. First things first, I'm gonna suggest that we get the equation for the asymptotes first. And I'll help you understand what that means by doing Desmos stuff, okay? Notice I've made a list, just like I did yesterday, of the 5 things. Center, vertices, co-vertices, foci, and asymptotes. Those are all exactly the same as they were before, except for the asymptotes. And notice, for vertices, it's transverse axis. It's not major axis anymore. Conjugate axis is the name of the other axis, the one that the curve doesn't cross. But I'll talk about that in context here. Okay, first things first. We need to get everything about this, okay? We need to get our vertices, center, co-vertices, blah, 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 blah. So let's do that. First things first, we know that the center is going to be 6. Oops, I already made a mistake. Centers at -6 and -10. That's the exact same thing like we did yesterday, so I shouldn't have to explain that. The asymptotes, just watch, okay? Trust me. The formula for the asymptotes, I'm just going to write down here. It's always this, plus or minus something over something. And then the something that I'm talking about is depending on which one's y related and which one's x related. So let me write it out. Look, asymptotes, y minus k. I can steal this, so it's y plus 10 equals plus or minus. I'm going to leave it for a second. I'm going to steal this one, x plus 6. And then which number over here is under the y? Well, the 16 is clearly under the y. You're going to get the square root of that. That'll go on top. And so that will be 4. Well, root 16 or 4 comes from that, okay? Oops. On bottom, you get the square root of the other one. What's the square root of 9? 3. The reason that works, and we'll see it, I'll explain how it works when we get the diagram, okay? Let's just keep going. So this is our asymptotes. I'll graph that later so you can see what I mean. What's the next step? What was the next step when we did ellipses? Well, we got a squareds, b squareds, c squareds. Let's do that. A squared. Now, careful. Because x comes first, it's going to look like this when we finish. With our focus out here. That must mean that the a is related to the x, okay? That's our transverse axis going through. So our transverse axis will be in this direction. So that's our a. A always comes first. So it's this one is kind of what I'm getting at. A squared is 9. It's no longer a major minor. It's just related to the first one. So what's the square root of that? It must be 3. I'll get the vertices from that, but let's keep going. B squared. Okay, what's b squared? I'm assuming you're all paying attention. It's going to be 16 because it's the other one. It's the one that doesn't come first. It's the one under the second term. Doesn't matter what's on top, x or y. That means that it's the square root of 16. What's the square root of 16? 4. Thank you, Aisha. You're awake. Good. Now I'm going to keep going. I could stop here and get the vertices, co-vertices, but I want to keep moving. So I want to get the stuff related to foci. Now, c squared is what? For ellipses, it was a squared minus b squared. For hyperbolas, it is a squared plus b squared. It's just straight Pythagoras. A squared plus b squared. That means c squared is what? What's a squared minus b plus b squared? It's 9 plus 16. So I'm just going to go ahead and say c, that's 9 plus 16, square root of that. 9 plus 16 is 25. Square root of 25 is 5. So I did all that workings yesterday. I hope that that wasn't, it's okay if I skip it now. So can I just get a show of hands if this is making some sense so far? I haven't really done much different yet except for the transverse and conjugate.
Sorry, Mister, about the C, how it's five again?
You get the C from, let me just make an aside here. I'll delete this in a second. C squared is a squared plus b squared, yeah? C squared, that means our a squared is this one, b squared this one. So 9 plus 16. And c squared is 25. And c is 5.
Okay, thank you.
I'm just going to erase that because I don't really need all that extra stuff there. My computer is struggling lately. I'm not sure why, but sorry if that is annoying to any of you. Okay, so let me try to be clear here. Let me just quickly recap. This first one, whatever comes first, x squared or y squared, it's called our it's going to be related to our transverse axis, which is the axis that our parabola, or sorry, hyperbola crosses. Conjugate is the other one, okay? And so I'm just trying to keep some notes that you keep in mind. Now let's give the vertices. Vertices. What's it going to be? In fact, I'm going to sketch it first, and then I'll give those. Because just like the ellipse, the sketch is something that really helps you. Okay, so I'm going to go ahead and make a little sketch. All right, let's do this. -6, -10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me just shorten that. I kind of cheated. I don't know if that's going to work very well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay. -6 and 10 is our center. I don't know if I trust this, if this sketch is going to work out okay. I hope it does. I actually don't need to make a sketch, but I want to make a sketch because not all of you have seen the videos yet. So that's my center. My vertices are going to be along the transverse axis, and because the x comes first, it's going to go left and right because that's the x direction. I go left and right by 3. So 1, 2, 3 is about here. And left 3, and this is going to be tricky without graph paper. 1, 2, 3, left 3 from there is about here. Just do your best. This, I should have had a graph paper ready here, but it's not. It's just not in the book, so whatever. Those are my vertices. So I can already write down what those vertices are. Let's see, they would be, the y value stays the same, but the x value changed. So what's -6 minus 3? -9. -10, and then -6 plus 3, -3, -10. So if you're not sure where they came from, you know, I'm getting them from right here. You need to just, of course, it's tricky to see it on my sketch because there's not a lot of space, but that's how you need to get these things. All right. The co-vertices are done in a similar way. The co-vertices go from the center, but in the what's called the conjugate direction. Can you all hear me? My internet just like freaked out. Can you still hear me? Did that drop out? Okay. Let me know if anything goes wrong. Something really weird happened on my side just then. So from the center, go up by how much? Let's see if you're paying attention. How much do I go up from the center? 4. Yeah, exactly. Because of this 4 up here. So the center is currently at -6, -10. Be very careful. You need to go up and down so you affect the y values. So the -6 stays where it is. You go down to -14. And you'll go up from -10. Oh, my brain. That's -10 plus 4. -6. Yeah. So be careful with this. This is actually pretty tricky to get some of these. And then the foci is again from the center, add C, and go in the direction of the transverse axis, which is again the same as the vertices were. So I need to go, let's see, I'll add these. 1, 2, 3. Should have thought I had better on my sketch. The foci, they're going to go 5 left and right from the center. So I should get something like this. This is tricky to draw this, actually. 1, 5, 4, 3, 2, 1. And 7, 8, 9, 10, 11. It's going to be something like that. Again, I really should have done one of these on graph paper, but there wasn't graph paper here, but some of you didn't watch the video, so it's important to know how these sketches work. I just chose a bad example, I guess. But that's where my foci are going to be. So I'm actually going to make a choice here. I'm not going to write in, I'm going to take the foci off the graph, but I'll write this down. What are the foci? So the center, what's -6 minus 5? -6 minus 5, -11. What's -6 plus 5? -1. Okay, so just so we're clear on this, the values that are changing each time are these, okay? I don't know if that's helpful or not, but just so you know, vertices in this case, X, co-vertices in this case, Y. Foci, same direction as the vertices. All right, let's make the magic happen now. I'm gonna zoom in on this a little bit. I know that some of you can't do that, but I'm gonna do my best. I'm gonna draw my box. This is where the box will be with the A and the B values. Draw straight up and over. Draw down. Make a box out of your points from A and B, your vertices and your co-vertices. Box them in a perfectly, or at least close to, square box. And then what you do is, and you should have a ruler for this, you really should, connect the corners of the box, draw lines. Draw 2 lines. They'll be our what we call asymptotes. So I can do this like this. Hopefully you have a ruler as well. I'm going to connect them. Okay. And then I'll go the other way. And I'll do my best, just like you can only do your best. Those are my asymptotes. And I'm almost done. I know this is different from the ellipse, but when we look back on it, really the drawing is the only main difference. Everything else is basically the same. Now what I need to do is I need to draw the actual hyperbola, which I know will look like this. You can see that. My internet's not doing great today, but hopefully you can see that. So I'm just going to draw it. It comes along the asymptote, down to the vertex, and then curves out again. It never touches the asymptote. So it's something like that. I'm actually going to redraw that because that wasn't very good. Sort of like this. And it'll go in both directions forever. And like this. That's my hyperbola. I'll put this on Desmos after so we can see that we are getting exactly what I'm saying we're getting. Have I gotten everything? Actually, yes. I have my vertices, my co-vertices, my foci. I have my equation of the asymptote. It's up there. So I'm finished. Now let me remind you why I was able to get the asymptotes so quickly. The asymptotes in this case were plus or minus b over a. Why was it plus or minus b over a? I'll connect it with colors here. The b is related to the number under the y, just like rise over run, okay? Think of rise over run. Go up, and you have rise. Up is related to y, okay? Run is in your x direction. So the rise is the number underneath that, or the square root of it, and the run is the number under the x, the square root of that, a. Of course, it's the square root because what's under it right now is a squared, not a. So I know this is a lot to get in your head. We're going to do example after example after example today, but this is the first of many, okay? The first of many examples. So how is that? How is that sitting? Easy. Okay, okay. So I'm going to quickly show you what this looks like on Desmos. Can you tell me, by the way, is my video lagging for you, or is it okay? Because on my side, I'm looking at my monitor, my video is really choppy. Okay. Yeah, I think my other laptop's just having a really big difficulty. Okay, let me graph this. Just so you can trust me when I say that we've done what we said we've done. So I'm going to graph the original equation. Oops. So over here, I'm going to have a fraction minus another fraction equals 1. Oh, before I forget, I need to remind you here. How do we know that this was a parabola in the first place? How do we know it's not an ellipse? And it all comes down to this. Let me show you. In this column. This sign in the middle. For an ellipse, the sign between them is positive. For a hyperbola, the sign between them is negative. The x and y stuff is still squared. The only difference is that sign, okay? So as a very short recap, parabolas just have one thing squared, x or y. Circles have both squared, x and y, and they're added. Same thing for the ellipse. A hyperbola has both squared again, but one is minus, okay? So I'll recap all that later, but I just want to, okay, let me graph this so I can show you what it looks like. Square that, divide that by 9. Y plus 10, square that, divide it by 16, and equals 1. Okay, look at this beautiful thing. That's much nicer than the one I made, but it's basically the same. How do I know it's the same? Well, I'm going to test a few things. I'm going to put in my vertices. Okay, I'll only do this once because it takes a bit of time, but I want to prove it to you. -9 and -10. Let's put that on there. Let's put -3 and -10. Oh, my vertices are labeled. How fancy. Let's put in -6 and -14. Let's put in -6 and -6. Okay, that's a box. I don't really need those, so I'll take them off actually for now. And then our foci, -11, -10, -1, -10. And they are inside the loops. Remember, if I was to shine light into these hyperbolas, that's where the light would all focus in on. And the final thing, probably what is the most important thing, I'm going to graph the asymptotes. And what we should see is that the curve follows the asymptotes perfectly. So I'll graph my asymptotes here. Y plus 10 equals +4/3, x plus 6. Oh, dude, x plus 6. What am I doing? There we go. And then y plus 10 equals -4/3, x plus 6. Okay, sorry, that took a little bit of time, but it's important, I think, to see it. Look at this. I have my asymptotes, I have my vertices, I have my focal points, and I have these lines here, this purple and green lines. They're my asymptotes that the hyperbola follows. Okay? To me, I think it's pretty cool. And do you know what? If I was to change one single thing, if I was to change this minus to a plus, do you know what would happen? If you've been paying close attention, then you'll know what would happen. And it means that you really understand this stuff. If I was to change that single sign to a plus.
Circle.
Ellipse, yeah. I get an ellipse that is kind of inside that. All right? And that's kind of cool. Like, it's kind of like you took the ellipse and somehow like bent it through time and it just explodes out the other side. But they are directly connected. Many of the same things are related. Look, even if I put the co-vertices back on, we can see them there just like they were, okay? So these things are directly related. Okay, so I didn't want to overwhelm you with that. I just wanted to help you see the connections between everything that we're doing. Okay, so for C, I'd like you to try. I might not do a sketch for it. I don't know if it's the nicest problem for a sketch. Let me look ahead and see if there's space for a sketch. I'll leave this one just for homework later, actually. I want to start one with some graph paper because it'll be much more useful. Tom did this in the video, but I want to do it from scratch. Okay, just because I want to do some ones that have graph paper. So let's get started. First things first, I suggest that you do the asymptote first. So what are the asymptotes? Can someone tell me what it's going to be? I know what my equation is. It's always this. Plus or minus b over a or a over b. So I need to fill in the blanks. What's y minus k? Someone tell me. So I'm seeing 16 over 4. Be careful, you got to get the square root of those. So y minus k, I'm saying y plus 1. Why am I saying y plus 1? I'm stealing it from here. Now, I'm going to get x plus 1 over here. Why am I saying x plus 1? I'm stealing it from the original equation. Very, very simple. And then the 16 over 4 taric, you're going to take the y one, square root of it. That's going to be 4. You're going to take the x one, square root of that. We're going to get 2. And that's what we're going to put in here. So it's actually going to be plus or minus 4 over 2. And if you want to, you can simplify it and make it plus or minus 2. It's kind of up to you. So yeah, plus or minus 2 is probably better. But that's the idea. I'm going to erase some of that. Okay, so we already have our equation for the asymptotes. And that's 2, just so you know. I just want to keep what I had there. So let's go through the motions. Let's do it again. Let's do the same thing we were doing yesterday for the hyperbola. Center first. Where's the center? The center is at -1, -1. So I'm going to write that on my graph paper. If you don't have graph paper, you're going to have to sketch it on a piece of paper. You should get graph paper, or you should try to print the notes somehow. -1 and 1, right there. That's our center. Let's keep going. A squared. Okay, stay awake. Which one's A? Which one's A? 4. Thank you, Tarek. A, in this case, for hyperbolas. It's easy to get this mixed up with the ellipse. It's not the biggest one anymore. It's the first one. It's always the first one for hyperbolas. So in this case, it's 2. So I'm just going to go ahead and do this. What's my shape going to look like? I already know ahead of time what this is going to look like because I know that my x is coming first. Yeah. Oh, good. I like that. I like using the, that's a good idea, using the brackets. I never thought of that. It's going to look like this, and our focal points are going to be on the outside. So there's going to be focus hanging out there. Good job. Thank you. And so we're going to go left and right. That's where our transverse axis is going to be. So if I wanted to, I could draw my transverse axis through this, but you don't need to. I'm going to go left and right by 2. 1, 2, 1, 2. There we go. So I'll just write my vertices. Vertices are going to be left by 2. So the center, it's already at -1. Go left by 2, or -1 minus 2, -3, and -1 plus 2, 1. Okay. Stay awake for this. This takes a lot of brain power to make sure you don't make a mistake. Let's do B. B squared in this case is 16. That means B must be 4. That means my co-vertices, my conjugate axis vertices, go up from the center by 4. Okay, let me make sure my colors are consistent here. Go up by 4. 1, 2, 3, 4 up top here. 1, 2, 3, 4 down here. You're saying -3 and 3. I don't know about that. That's not what I'm seeing here. I'm seeing something more like -1 and 3. And -1 and 1, 2, 3, 4, 5, -5. So check that, Tarek. Make sure that you didn't make a mistake there. Okay, so actually we don't even need the focus right now. We do need to get the focus, or the foci. But we can draw our box, we can draw our asymptotes, and we can even draw our parabola, or sorry, hyperbola now. It's very important we don't say parabola because they are not the same. So you should use a ruler for this. I'll put my ruler up. I'm going to draw a box that connects their A's and B's. Okay. It's faster to do it by hand without a ruler, but of course it's not as nice, not as accurate. So I'll just do this with a ruler this time. This is about how long it takes. Oops. Okay, and there we go. That looks about right, yeah. So that's my box. You don't need to make it solid lines. You can make it dotted lines. I don't really care because the main thing is that you draw the hyperbola accurately. Now I need to go down through the diagonals. Again, use a ruler. I'm going to make my asymptotes. Just do it the best you can. I'm going to go down through here. My asymptotes. 65 degrees in this case. I love this little tool here. It tells me my angles. Fancy. Okay, 1, 2. Okay, that's about right. Those are my asymptotes, and this is where you really need to think. And this is why I like to make this sketch up here, because it saves some of the thinking for me. Because I know the x came first, I know it's going to look like an x, so I don't have any thinking to do. I can draw this hyperbola very easily. If I hadn't thought about that ahead of time, some students might go, okay, well, this is my hyperbola. And that's not right. It can't be right because that's not the transverse axis. That's not our main axis. That's not the axis that we need to draw it on. Or in other words, you know, because x comes first, it needs to go through an x point. So it should look like this. So that's the best I can do, or about. And then follow the asymptote, and it should look something like this. Again, not perfect. The important thing is that you go through the vertices and you do not touch the asymptotes. That is the definition of an asymptote. It's a point that, a line that you are not allowed to touch. You can get infinitely close, we can say, like very, very, very close, so small that you can't even tell the difference, but you're not allowed to actually touch it. Just the way it is. Now I'm going to calculate the focus. C squared is A squared plus B squared. That means C squared is 20. That means our C is root 20. If you get root 20, it's 2 root 5. Or in other words, what's 2 root 5, just so we can get to the decimal later. 2 root 5 is 4.47. So let me draw that on my drawing here. I got to go left by 4.47 here. So from the center, 1, 2, 3, 4.5 or so. 1, 2, 3, 4.5 or so. Okay, I'm going left and right by that from the center. Not 0, 0, but from the center. Lots to keep in your head. Like really, this is an exercise in not memorization, understanding, and absolutely practice, okay? 100% practice. So the foci, I'm going to take my center point. I got to go left. So this is going to be -1 minus 2 root 5. Keep the same -1. And -1 plus 2 root 5, -1. Again, let me make this clear here. I'm changing this part. Those colors don't go together very well. Sorry about that. Maybe this. Still doesn't go together well. Sorry. I don't want to end up with notes that you can't read. I'm relating it to that. I've got to go left and right by that much on the focus. So I add it to the x value of the center and I subtract it from the x value of the center. You can also say -1 minus 4.47, -1 plus 4.47. So I'll do that just so we're all clear. That would be -5.47 or -1 plus 2 root 5, 3.47. Okay, just so we're all clear what's going on here. And this is basically it. We have everything that we could possibly need. And the asymptotes, I'll write it in here, asymptotes. There's 2 of them, plus or minus 2x plus 1. Whew, man, these tire me out. After doing a whole bunch of ellipses yesterday and then this today, I'm going to be a zombie by 5:30. Okay, everybody, we're not done the topic, but we're kind of done the topic. We're not done the practice, but this is honestly all there is. Like, if you understand that A is from the center to the vertex, if you understand that B is from the center to the co-vertex, if you understand that C is from the center to the foci along the transverse axis and all that, you just need to play with the stuff until you figure it out, okay? Anything about this particular question I can review? I'm just going to keep doing more examples.
Yes, sir.
Yep.
We sum C with the lowest number.
Say again.
We add C to the lowest number always.
No. You add C to, in this case, you have to add C. You notice what I've highlighted here? This yellow and yellow. So let me try to be as clear as I can. Let me draw a little sketch here. So let's just say this is what our hyperbola looks like, okay? Or let me, actually, I don't need those values. I need this, and we have the center in the center here, okay? Are you following?
Yes, Mr. I'm with you.
If the graph looks like this, C, now this, if the graph looks like this, it means that our axis is in, this is like our main transverse axis. That's what where the vertices are going to be. It's also where F is going to be, our focus. So the focus is going to be somewhere out here, okay? It'll be somewhere on the other sides. And in this case, that means we need to subtract C from the center, the X value of the center, and we need to add C from the X value. So in other words, in this case, the focal point is going to be the X value of the center minus C, and then you have to keep the Y value. I don't like to write it out in math because it just gets really confusing, okay? So I'm not actually going to do that. Just remember, if you have something that curve that looks like an X, your focus, you have to add that C value to the X value, which is why I look over here. In this case here, we had our center. I subtracted C from it. I got to that X value over here. And if I add C to it, I get to that X value over here. The Y value doesn't change, you don't touch it.
Okay, if the sketch is up and down.
Yeah, so if the sketch looks like this, so we have a hyperbola that, and we'll do ones like this, that would be if Y squared came first, let's just say like this, okay? This would be the form for this. That means that our main axis, called our transverse axis, is going up and down. That also means the center must be here, right in the middle, and our focal points are going to be up here and down there, and our vertices are actually going to be here. So these are the two things you need to be aware of. This distance here is C. This distance here is C. So you add it and subtract it from that value for the center. You also should know that if you have that, this distance would be A. This distance is also A. I didn't mention that here, but I could have. Okay. Just trying to keep track of everything. So let me try to make it as clear as I can. Your A values, everything starts with the center. So you have your center. If it looks like an X, then your center is going to have things added to the X values, mainly. So your vertices, you take your center and add A and subtract A from the X value of the center. If you want your focal points, your foci, if it looks like an X, you add and subtract C from that X value. Okay? But I find that it's hard to think of it's hard to listen to these explanations. Like you kind of just need to see it and think through it and see the examples. I could talk all day about it. It might not help you more, okay? So I'll do more examples. Is that clear for now?
Okay, Mr. Can you make example for the right one?
Yeah. I'm going to do that now. I got you. Don't worry. I got you. So in this, there are only two cases, yeah? There's the X style, which means that the X squared comes first. It's the positive one. There's also the Y style. Oops, I didn't mean to erase it. The Y style, where Y comes first. So it's going to have a curve like that and like this. Kind of like, I don't know. I don't know what it looks like. But we know it's going to look, what?
Let's see.
Let's see. I know it will look like that, okay? Smiley face and sad face put together. I don't know, whatever. So we know that because the Y squared came first. So I call it the Y squared first type. All right, the focal points are going to be up and down based on that. So Tarek, you said y. I'm assuming that you know that's the same thing we're talking about here. So I'll do the asymptotes last this time. We can do it first. Okay, I'll do it first. I know that my y, it's going to be y minus 2, plus or minus this square rooted over this square rooted, so 2 over 4. I'm just going to sketch that down here just to show you we can get asymptotes right away. They're very fast. And the only thing that's tricky is this thing, rise over 1. Okay? So let's go ahead and do our regular thing. I'd like you to do it with me. If you want to follow along, of course, follow along. But please, please, please try this. You know, I want you to keep trying it on your own. I'm going to do lots of examples today. I'm going to keep going until I fall asleep, basically. Okay. So a squared is the first one. Not the biggest one, the first one for hyperbolas. That means a is 2. I didn't write my center. I should have written my center out. It's important to start my sketch. Center is at, ooh, what is my center? What's my center? What's my center here? Does someone know? I was about to make a mistake. 2 and negative 1. 2 and negative 1. 2 and negative 1. Are you sure? Aisha wins the prize. Mysterious prize that I seem to never be able to give. Yeah, Aisha got it. This is h. It relates to the x value. So that's a mistake that I personally make a lot. I'm surprised I didn't make it this time, honestly. Notice that these are backwards because your center is x and y value. Negative 1 is an x value, 2 is a y value. And you can see that because of where they are in the brackets. So it should make some sense. Okay, moving on. Let's draw this. Negative 2 and negative 1 and 2 is up there. I've made it on my drawing. Let's go one step further. I know that my a, I have my a value now, it's 2. I know that it's going to be up and down because that's my direction. That's where my vertices are going to be. They're going to be up and down from the center. So 1 is right here, and 1 is right here. So now I can draw it. So that would be negative 1 and 1, 2, 3, 1, 2, 3, 4, negative 1 and 4, negative 1 and 0. Those are my vertices. You add and subtract from the center. So if you have a center, you go up by A and you get your vertex. You go down by A and you get your vertex. So that's y values are being affected, not x values. Let's do B. B squared, 16. B, 4. Left and right from the center by 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, same thing as the ellipse so far. I could actually draw an ellipse now if I wanted to, but it's not an ellipse. So go vertices. That I'm just going to look for my sketch, so that would be minus 4. So minus 5 and 2. And add 4, 3 and 2. And I can get it from the graph, or you can get it from the logic, you know, adding 4 to the center, subtracting 4 from the center, x values. Okay, now I'm going to do the box. Box, box, box. Box, 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 box. Box, 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 box. I have a 2-year-old child. I sing to him all the time, so I probably shouldn't subject you all to that. Okay, let's make our asymptote. I'm doing the best I can. That looks close enough to me. Again, you should be using a ruler on your own page. That's why I'm modeling it here. Asymptote, 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 asymptote. Does it ever an asymptote can? Okay, I messed up my asymptotes here. I think it should have been 25 degrees down there, but you know, I'm just gonna have to live with it. I'm gonna have an imperfect hyperbola, but that's okay. And then at the beginning, remember, I was like, I should probably think ahead of time what this is going to look like, because otherwise I might sketch it wrong at the end. So it's going to look like this, which crosses through the y-axis. I could do better. Okay, it should probably come a little closer to the asymptotes. Something like that. Again, we're never going to be as good as a computer, but we can get good enough. This is still quite an accurate sketch. So what am I missing here? I've got vertices, co-vertices, I've got my asymptotes, I've got a lot of blank space. Probably missing my foci, yeah? Foci. C squared is a squared plus b squared. A squared is 4, b squared is 16. Just in case you lost track of that plot. They're right there. That means that C, well, 4 plus 16 is 20. 20, square root of 20 is 2 root 5. That's the same as last time, yeah? Same as last time. I was like, have I been doing the wrong question this whole time? No, it just happens to be the same as the last time. So let's get that as decimals. Again, I know what the decimals are. What was it? It was 4.47. And let's see, Ahmed, can you tell me how I use this C to draw it on the graph? Where's it going to be? Is it going to be up and down, or is it going to be left and right?
Up and down.
Yeah. So you go from the center. So wherever the center is, currently the center is at -1 and 2. So you need to go up from there. Yeah, you need to go up from there by 4.47 or so.
Plus
Don't
2.
worry about changing the x values. So 1, 2, 3, 4. It's going to be about 4.5. 1, 2, 3, 4. 2, 3, 4. It's going to be about 4.5 downward as well. So those are my foci. That's all you need to do. You just need to put points there. So what's that going to be? That's -1. And I'll give you the decimal answer this time. You saying something?
Yes, 2 plus 4.457.
Exactly. So I'll give you the decimal just because some students prefer that. They find it easier, which I don't blame you. It can be much easier. -2.47. Okay. And again, you can call that, you can use the radical if you want the square root stuff, but not necessary.
Sorry,
I'll
Mr.
read it. Huh?
Sorry, I have a question.
Yes.
A is with the y, right?
No, A is, in this case it is, yeah. But A is always related to what we call the transverse axis. So let me try to make it clear. I'll just scratch this up here. Whatever comes first, in this case Y, that's what A relates to. It's also what C relates to. Okay, whichever one comes first. So in this case, it's all adding to Y. For the previous example, X came first. So this and this are added to the X values.
No, I'm talking for the first step that you start with, that you plus, that you add with the center, the vertical, the left one, down, the vertex, this one, -1 and 4.
Yeah.
Yes. You add the 2 for the y.
Yeah, because this started with Y.
We don't look in this way. We don't look to the biggest number or the small number to find the
No, and I know that's what's confusing about this, because for ellipses, yesterday, I made a big deal about saying A is the biggest number. You went with that. But it's different for this. That's why you need to get practice with both. If you don't do the practice, you'll get them confused every time.
Okay, thank you very much.
Any other questions?
Sir, why is 2/4 there and the equation?
So it's a version of like rise over run, yeah? So it comes from this. This is our y related value. We get the square root of that, because again, this is a squared. This here, let me try to make it clear. This is going to be plus or minus a over b. because A is related to the y and B is related to the x. That's rise over run, slope. So, or in other words, look at this way. This distance here, you see where I'm drawing? This distance here is 2. This distance here is 4, so rise over run, 2 over 4. They're all different ways of saying the same thing, but this is the root, well, this is just A, and this is B. The reason I chose those is this one is the y, it's under the y, which means it's the rise, it goes on top. This one is with the x. It's the run, it goes on bottom. Lots of little concepts here. I'm not going to pretend that it's easy. It's not easy. It's very long. They're probably the longer questions in the whole course, actually. But when you do enough practice, it will become more clear. There's only so many different ways I can ask this question. So I'll write the final answer here. So this is y minus 2 equals plus or minus 2 over 4 is the same as plus or minus 1 over 2. X plus 1. Okay, so these are our final answers. I haven't put them in boxes yet, but of course, these are the things that really matter. Just in case you're curious. I'm going to quickly check my answer on Desmo, so I'll put my answer up here. But I want to be sure that I'm right. We'll just do the basics. Let's see. So this, I'm just checking my numbers. I'm expecting to get a Y curve, and I'm expecting the asymptotes to be correct. So this is this guy. Okay, it looks pretty good so far. I mean, that's almost identical. If I make it small enough, it's pretty much what I wrote. So that looks good so far. I'm going to make the asymptotes. I'm going to put it in my asymptote equation. X plus 1. All right, crosses down. Perfect. Y minus 2 equals 1 over 2. Oh, minus 1 over 2. X plus 1. Okay, so I know my answer is correct. I graphed my hyperbola and my asymptotes. I can see that it goes perfectly along those lines. If we zoom out, the reason they're called asymptotes is because they try to match those lines. You can't even see the hyperbola anymore because it's so close to the asymptotes. But if we zoom in, they're actually not touching. Oops. They never touch. If I follow along the line, they never touch. They get close. You can see they're getting closer and closer, but I can always zoom in and see that there is a difference between them. And that'll go on forever. You get the idea? That's what an asymptote is. I'm going on forever. It never ends. Just looks like it touches. Okay. I'm tired. I have like 2 more hours, 2.5 hours of class left. Let's do some more examples. Anything you want me to clarify on this before I do the next one?
But this asymptote, this the formula of the curve line or not?
What was your question?
This is the formula of for the curved line.
Asymptotes are the formulas for those straight lines, that the x's, like the x. So the asymptotes are these.
And the black one?
Is the hyperbola.
Okay.
So the asymptotes are those lines. The hyperbola itself is, of course, what we've been talking about this whole time, these. That's what they're called. Those are the hyperbola. These are the asymptotes that go, that's the ones that they try to touch, but they never do. Okay. So again, that question was done by Tom. In fact, I think both of these were done by Tom. Certainly this one I just did was done by Tom, but I wanted to make sure that it was done by me as well because they're good examples. 3 was done by Tom. So I'll skip that, I'll do a different one. 4 was also done by Tom. 5 I wouldn't do because, well, I mean, you can try it, but it is a challenging question. I wouldn't ask it on a test or an assignment. Let's try another one. I want you to take 3 or 4 minutes. Tell me what you get for B, okay? Just tell me your coordinates. To practice, it says graph, but really just give me your coordinates, and that'll be enough to know if you've done it correctly. And then I'll give you my final answer for this, okay? So take 3, 4 minutes, 5 minutes maximum. I'll say like 3:20, and then we'll come back and see what everyone got, okay? Give this a shot. It's 320. I've got a center. That's the only thing that I see in the chat so far. A center. The graph, for some reason, is really badly made in order to let you actually graph it, but you should still be able to get the coordinates. Did anyone manage to get anything else? I'll put my solution up in a second. Y plus 8, 6 over 5, x minus 2, not equals 2, but x plus 2, sorry, not equals 2, but yeah, same basic idea. A is 6 and B is 5, perfect. That means that c squared is those two squared and added. So c squared is root 61. I'll show you what I have. I did it while we were waiting. I got this. Vertices negative 2, perfect. The other vertex is tricky. I put it in highlighted in blue over there. And that's because it doesn't actually give you space to put it. So that was weird. I'm not sure why they chose to do that. Maybe it was a mistake. But yeah, negative 2 and negative 14. You still take the center and just subtract 6. So if it's negative 8, it's negative 8 minus 6, which is negative 14. So you don't actually need that to make the graph. It's tricky to make the graph without it, though, because how are you going to make that box? You know, I couldn't make the box properly. Co-vertices 3 and negative 8, perfect. Okay, so I hope that those of you who are not writing your answers in here, I hope you're at least giving it a try. Again, these are not, the word for it in math when something is not really, really basic and easy is the word trivial. So I would say this is not trivial. It takes effort. Like 1 plus 1, that's trivial. 2 plus 5, that's trivial. It's easy, anyone could do it. This is not something anyone could do. This is something that takes practice. C is 7.8. Yeah, I said 7.81, same idea. But I think we're getting there. There's only one other type of problem, really, that, man, my nose is itchy today, sorry, that might cause a little bit of trouble, and we'll do those a little after. Okay, negative 2 and negative 0.2, yep. And then you should get negative 2 and negative 15.8 if you got the same thing I did. I'm just looking to see if we have the same solution. Negative 15.8, yeah, okay. So Tarek, you've officially answered all the questions. I can't see your graph unless you were to post it. You can post things. I mean, you can click the file button and give me a picture here. We could do that, but it takes a little bit of time, so I'm not going to bother. I will do one more, Ahmed. I'll do probably C. And once we do C, we'll move on to a couple different ones. We only have this page and the next one left. And then we're done all the types. After that, it's just a few extra types of problems after this, but not new shapes. Are we good with that? Can we move on? You can just take a picture of what I have or watch the video later if you didn't get my full solution. You should have your own version of it already. Okay. So this is what I would normally do in class if this was face-to-face, and anyone who was in physics with me would know that. I think it's just you, Ahmed, that I had before. Have none of you, or Ibrahim, of course. I didn't have, and Yaya, I didn't even see there, sorry. Have any of you had me with physics? Because I was the physics guy for Mr. Wilf's labs last term. And sometimes I see names on the register and I'm like, did I have you before? And I don't know, because I've had a few students with the same name. Anyway, that was just me curious. If I've had you before in a class and I somehow don't recognize you, or if it's been a physics class, like a physics lab, let me know, because I like to put a face to the name and I don't know what most of you look like. Okay, what my point was, if this was in class, I would normally say, look, if you want to try it yourself, just ignore me, but I'm going to be up here doing it and talking about it. So give it a shot. Yeah, of course, I had Yahya, I had Ibrahim, and I had Ahmed, and that's it. So I don't think I had anybody else on this list. No one was so lucky. Okay, let me talk through it. I'll stop wasting your time. So you got lots to do today, I'm sure. So first things first. Hey, there's an X first. That means it's going to look like an X. The transverse axis is the axis that the parabola touches. So that's where my vertices are. That will also be where my focal points are. So right away, everything like X is the name of the game. X is what you add and subtract A from. X is what you add and subtract C from. The only difference is B, but B is the conjugate or it's on a secondary axis. So I've got that. I'll do my asymptotes at the end. So what's the most important thing? The first thing is to write down the center. That's where I start my sketch. It's at 3 and -1. So 3 and -1 is over here on the graph. Okay, I'll write that more clearly. 3, -1. Now that I have my center, I move on to get my vertices, as usual. I get a squared. That's the first one. It's 4. It's 2. Can I get my b squared? That's 9. B is 3. Can I get my c squared? That's just 4 plus 9. So I take my two numbers, 4, and I add the other number 9. That is a squared and b squared. And then I just square root that. So that's 13, root 13. And there's nothing wrong with you writing it as a decimal if you feel like it. That would be 3.61 if you're curious. Thanks, Ted. Maybe I can just count on you to be my little calculator over there. It would be helpful. So before I do anything, I'm going to sketch them. I find the sketch helps me find the vertices, not the other way around. I already know that my transverse axis, my main axis, is the x. So I'm going to take away 2 and add 2. Those are my vertices. I'm also going to take away 3.61 and add 3.61. So go left, 1, 2, 3, and a bit. That's my focus. Hopefully you can see that. 1, 2, 3 to the right, 3.61. That's my focus to the right. I've got my focus to the left and right now. And I can make my box, let's see, b equals 3. So I need to go up from the center, 1, 2, 3. Down from the center, 1, 2, 3. Now I can make my box, and I'm done. The rest is just filling in the blanks. Okay, I'm going to freehand. This is a bad idea, but I'm going to do the best I can without using a ruler, just to make a fool of myself. Oh, that's not so bad. I could have done worse. Let's see. Yeah, that's not too bad. I mean, I might not get a job doing drawing by freehand, but for a straight line with no ruler, I feel pretty good about myself. Okay, let's see. It's going to look like this. Oh, is that really what it looks like? That seems ugly. Very stretched out, huh? And the other way. Something like that. Make sure you don't touch the asymptote. That's a big, big no, 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 sir. La. We do not touch the asymptote. That's the whole point. We're not allowed to touch it. I'm going to steal all my points from the graph now. You can do that in whatever order makes the most sense to you. I like to plot them first and then go back. And because I have colors, it's really easy for me. If you're doing all this on paper with a pencil, you might want to do it step by step so you don't lose track. Well, my colors keep me organized, and I do it for you as well to help you understand what's going on. So let's see. This is 1 and -1. And 1, 2, 3, 4, 5 and -1. My covertices are going to be 3 and 2, 3 and -4. Okay, my foci. It is also related to the center. I need to add 3.61 to 3. 3 plus 3.61. 6.61 and -1. Take away 3.61 from 3. 3 minus 3.61. -0.61 and -1. You might want to check those. I don't know how confident I am. You could also write it as this. I didn't do this last time. I just want you to be clear what I'm doing here. Some students really prefer to give the exact answers. As a student, I like the decimals. As an instructor and as an adult now, with more experience, I also like to take the exact answers. I feel like I'm not losing information. But it's all the same, really. You do what makes you feel most comfortable. Asymptotes. What are they? This is one of the trickier parts if you don't get the trick that I gave you. So what are the asymptotes? I'm going to steal the center, y plus 1. I'm going to steal the center again, x minus 3. I know it's plus and minus, and I know it's a fraction. You just give me the square root of the y1 over the square root of the x1. So the square root of 9 divided by the square root of 4. Or in other words, put b on top and put a on bottom. So it's b over a. Plus or minus b over a. Thanks, Ayesha. You beat me to it, I think. B over a. There we go. We got everything we need. Vertices, covertices, foci, asymptotes, and a decent sketch that I probably should have used a ruler with, but I'm sure that if I ask you to graph this, you're going to use a ruler, yeah? Make sure you own one. If you don't own one, at least use the side of your phone is what I tell students. Like, you might scratch up your phone a little bit, but you chose not to have a ruler, so, get fancy with it. Is it becoming more clear? Hopefully it's, for some of you, crystal clear, and for others, it's more clear than it was. Okay. I'm glad that you thought it was easy, Anya. I wouldn't call it easy. I certainly know that when it was taught to me, once upon a time, it was not easy because my instructor was not the best. So I found it very difficult to make sense of it. But I'm glad that you think that it's straightforward. The hardest part, I think, personally, I think the hardest part of this right now will be remembering which approach to take when you're given, parabolas, circles, ellipses, and hyperbolas, making sure you don't mix them all up. But if you do enough practice with them, get the practice in while you can, I think you'll have a clear idea of what the differences are, okay? And you got my notes to help you. So let's do 2 more questions. I'll see if I can finish them in time. These are a little bit different. They're like the ellipse ones at the end of the topic. They use a little extra information. So let's give it a shot. Write the equation of each hyperbola from the given information. So once again, we need to get the equation. That means that we'll either have x minus h squared over a squared minus y minus k l squared over b squared equals 1. Or we're going to have y first. So I'm just writing this out so that it's very clear what we're talking about. And remember, this left one looks like this. This one looks like this. So let's get started. Write the equation. First of all, vertices 8 and 14, 8 and negative 10. So I'm going to make a little sketch and see what I can make sense of here. 8 and 14, 1, 2, 3, 4, 5, 6, 7, 8. 14 is somewhere up there, okay. 8 and negative 10, 1, 2, 3, 4, 5, 6, 7, 8, 10. So down here somewhere, that's our vertices, and the conjugate axis is 6 units long. What do I need? What do I need in order to solve this question? Well, I need the center A and B. H, K, A, and B. How am I going to get that from this little information? Well, I'll try to help you. First of all, in order to get the center, it's going to be somewhere in here. It's halfway in between. What's halfway between 14 and negative 10? Well, that's surprisingly easy to do. To get the center point, you get the average. Add them together and divide by 2. the y value for the center is going to be, what's 14 minus 10 divided by 2? It's going to be 2. So it's at 2. The center is at 8, 2. All right, that's what we know. That's the first thing we know. And again, this is a little bit of puzzling it out, but you should be able to get this. The center is halfway between the vertices. That's the definition. This is the transverse axis. So that's the middle point. It's not to scale, but close enough. The conjugate axis is 6 units long. If the conjugate axis is 6 units long, the conjugate axis length normally is 2b. Remember, because we go b one way, we go b the other way. If you add that all up, that's 2b. That's the total length of the axis. So that if it says it's 6 units long, it means that it's 2b. That means that b is 3. So look, I already almost have everything. I have h, I have k, I have b. How do I get a? Anyone have any clever ideas how I'm going to get a? What is the definition of a? The distance.
This C square.
We're not going to need c squared. We're not going to need that. We can look, so I see Tarek thought a similar thing. We don't have c. Do you see that we don't have it? We don't have a, and we don't have c right now. So there's no way we can do c minus b. But what we can do is, if you remember what a means, a is the distance from the center to the vertex, which is a. I'll put it over here. A is the distance from the center to the vertex. So that distance, what is it? Well, that vertex up there was 8, 14. I'm currently looking at 8 and 2, so that distance must be anybody? I thought everyone was going to yell at 12.
12?
12. I expected everyone to go 12. That's never how it happens. That's only in the movies. So get the center. Second, we'll get that. Third piece, I know that a is 12. Another way you could look at it, it's this whole length here is 2a. So you could add it up, but I find it easier just to get the half. Any way you can get a, that's fine. And then we get a squared. What's a squared? What's 12 squared? It's 144. What was b squared? B squared was 9. I'm getting the squares because that's what's in the formulas. Okay. Hopefully that's not too much to take in. Now, of course, we need the equation. What style of equation is this going to be? Well, it's going to look like this. I know that because the vertices are up and down, which means it's going to cross the y-axis. So long story short, it's going to be y minus k. What's my k? My k is, I thought I wrote this down somewhere. Maybe I didn't write it down. I thought I wrote it down. So my center is 8 and 2. So it's y minus 8. Oops, y minus 2. I'll make this clear in a second. Hi, Yasser. I'm starting my class in 10 minutes. I think you're early for your class, Yasser, unless you're coming late. 144. I'll color code this in a second. H minus, or x minus h, so that's h is 8. 9 equals 1. Okay, let me color code this so you know where everything came from. Y minus 2, this is my final answer, by the way. The minus 2 was the y value of the center. Yeah, it's not your class, Yasser. You got 10 minutes. See ya. X minus 8, where did that 8 come from? It came from the center. And finally, of course, where do these values come from? That's a squared and b squared. I guess I could have used a different color for b, but I'm sure you can understand what I did. Okay. The other questions in this section are very similar to that. They're all a little bit different, but they're all very similar to each other. So there's no reason why you can't try those. Those are pretty standard types of questions. They tend to get asked on tests. I'm not going to say they will be, but because there's a teaching team of 4 of us, it's whatever they all decide on, including me. So you've got to know how to do anything in this chapter that I don't skip. Okay. So I hope that's clear. You'll definitely get questions on this earlier stuff. There's no question about that. You'll definitely get it. Okay, I'll stop the recording here. Bye-bye, everybody.